for anybody who's trying to test or build a reactor, step outside the present way of thinking and do not go to build things. Go to create condition to achieve. This is part of the problem that because of the pressures we came under, and as you know, why that was one of the reasons we left Belgium, because of the pressures through government. And one of the excuses they had was that we use nuclear materials. They thought by pressurizing us not using nuclear materials, our research stops, but that pushed us to bring the program of non-nuclear reactors forward by maybe 10 years. Thank you very much to the Belgian authorities. This has made the use-based technology more or less obsolete. A lot of it obsolete. Even on our material and on other sectors of the technology development, this new reactor, if it supplies or it delivers what is planned to do, make even the present patterns obsolete. Because it literally jumps the whole knowledge gap to another step. This brings a lot of things in order in us understanding it. Then there is a problem. Do we pass this information to public without the patent publication? Or do we release it on a forum like the paper with the homeopathy? Because the gap between the present development and what you lot are developing is huge, is gigantic, is a huge step. But we have to see. I'm very, put it this way, I hope I'm 60-70% sure that we'll achieve it. But then that opens a totally new concept in development of the technology in energy and motion, and makes it more advanced. Every time we thought we reached the what I call as far as we can go, we find out we haven't gone far enough, and we discover more things. We are pushed to activate more things to do. This is very much, you know, a lot of people are listening to these talks, these lectures, or these workshops, and then they pick things on it and they send us all sorts of threat letters. We do this with you, we do that with you. Everything we do, everything you send us, all the threats goes in the hand of national securities. All your things are well documented. So when we talk, when we release information, is for governments and for scientists who understand that level to get join in and activate and test. It is important that we pass a limited amount of knowledge, not all of it. If we release all of it, it can cause a lot of problems for us, and it makes things a nonsense because people don't understand it. When they don't understand it, it becomes a fairy tale. So as a lot of people are testing these reactors, now people are getting connected with. They are understanding more of it. So the next step is releasing more information in a different direction. Once a large number of people start, what do you call it, testing. The knowledge we are gaining with the new reactor, it is incredible. It's absolutely incredible how much even the reactors of 2 years ago have become obsolete. They have totally become obsolete because the knowledge gain has been very rapid. And there are people who are interested in the knowledge gain. It's not just a talk on something which is put on and is gone. The Chinese video I just look at, when I put it up with Mr. Cho, when we agreed with the Chinese guys to be able to put it on a forum, it was only 11 counts. Now I look at it's about 45,000, just a few numbers short of 44,937. So there is enough interest around the world to develop and to see what the Chinese are doing. The same thing happened with the Polish. The same thing happened with others. So the interest is there to create a new technology and develop further. But we cannot release everything we have. People don't understand it. We meet with officials, we meet with governments, we meet continuously with scientists around the world who understand that part of which is their expertise. But we cannot release all the USB sticks if and when this new test is completed, confirms the correctness is obsolete. We give the USB stick to every single man on the street because it's obsolete.
Yes, and besides that, you actually are releasing a lot of information, like you've already discussed. This what's coming up with we've got the learning program with the books and so on that's coming up. We've got various workshops that seem to be on a continuous basis, and there's numbers of YouTube videos and patents, and there's tons of information out there. It would take lifetimes just to be able to sift through it all, I think. So it's not like there's a lack of information in my mind. I mean, just the longer patent alone is enough to keep a scientific-minded person occupied for a year or so of solitary reading, I think. So.
Yeah, but let's understand something. We develop things. The problem with the foundation is, look at NASA. NASA has a public budget, has a black budget. Nobody knows what they're researching in the black budget. Nobody knows. The clear budget, or what is the public budget, is 18, 19 billion. The black budget of NASA runs into hundreds of billions. They never talk what they are doing. They never talk what they are developing. When they do something, they release a paper here or a video there. This is what we've seen. After they analyze and they find out the knowledge they release is more or less useless to the public. But with us, we release as much as we can, when we can, and what is available. So we have to keep certain research hidden, and I keep a lot of research hidden. That's for our own benefit and our own research. We receive a lot of pressure regarding our health program, that we took everything off the internet. But interesting enough, government officials ask us to open the health section. I'm not interested because we achieved what we wanted to do. We have found a solution to cancer. We have found a solution to ILS. We have found a 100% solution to MS. These people who make threat to us, it leaves other people in the world to suffer with what we have discovered. So the stupidity of a few has put a lot of people in the doldrum. When we show the success with our ILS, has shocked the health people. You know ALS you call it?
Yes, I actually was on some of the forums of the ALS people and informing about some of the catch technology. They couldn't accept it very well.
We have found the total solution to ALS. Total solution. And the whole thing has been monitored by doctors, not just because what we say. So is shelved. People thought they can make a threat against us. We do this, we do that. So now people who are less who could have had a way to find a way to the problem, now they are suffering with it out of the stupidity. So we keep a lot of knowledge to ourselves. We have found 100% solution to cancer, 100%, because the material is with doctors in hospitals and is kept. The tumor cancer, which has been treated, has been kept by doctors We work very closely with doctors, and these people come and make threats. So very soon these people themselves and their children will come up with the cancer and say they wish we'd never done that. But now it's shelved. It's gone under. So we only release a little bit of information for public consumption because there are a lot of people, what I call, who don't even understand it. But if you go on the health section now of the foundation, it's gone totally blank. We took it out. We don't need these things because we learn what we want to learn. And now the people who make the threats, soon they have to come and beg for the life of their own children, themselves, and the rest. All we do this to do with us now is in the hand of governments. They are doing the testing, the hidden research, and they have all our documents.
Mr. Keshe, along those lines, for people that are asking about can they get health benefits from the Keshe Foundation or some sort of get linked in, is there still any contact with or any program for people like that, or should they be just told that it's no longer happening?
Put it this way, we are in close communication with the governments. Governments have to bring it out from now on. If they decide to shelve it, they shall. There are certain people who listen to this program and they send us threats, and they thought because of the threats we took off. No, we handed over everything to the governments. Everything has been handed over to people who do, and then it's gone under what do you call it, is not in public domain anymore.
Right.
It's not that we stop, they frighten us. No, we don't get frightened. Now the technology on the cancer, technology on the ILS, is in the hand of the people who they decide if public deserve to have it because of certain stupid moves by certain people.
So at this point, we can just let folks know that it's at least temporarily suspended as far as the health program.
The health program is there are people who approach us through the health. We put them channels to different things, but we are not interested at the moment.
Right.
We curtail the health program in so many ways, but it's just because of the stupid threats we receive. And they thought they are very clever, threatening me or whatever. And now, very soon, in the next few years, they themselves, their children will come up with the disease. Because whatever you decide to stop or ban or do something turns out for you to be needing it yourself very soon. And then they beg for their lives, and then they say they wish they never done such a thing. But now it's gone into what they call blacklist of science. But we have found 100%. We have found a solution to ILS. Our MS research confirms the same kind of thing, and our cancer research, which we closed last August, confirms that we have found how you can change the cancer, cancer tumors to non-malignant. You still keep the tumor, you still have the tumor, but it's non-malignant, and the cancer is not there, but you carry the tumor. It's like the lumps you find on your head or in any part of your body which are there and do nothing. We have found out how the thing is done. We developed this material for it, system for it. It was tested, and we've seen the tumors have been tested by the hospitals, by the doctors who collaborate with us, and they confirm the non-malignancy. Actually, the tumor goes totally black while it's inside the body, which is very, very interesting. The tumor cancer, especially with the breast condition, pieces of tumor literally falls off. I'm sure somebody who listens to this workshop knows exactly because he was involved with it with his wife. These pieces of like 2, 3, 5 gram, 10 gram lumps of cancer of the breast just literally falls off in like 20, 30 pieces a day. So we have found how to get the body to reject any cancer, but the people who made the threat now, they have to beg for the life of their loved ones not to come up with such a problem. Because they beg for it and it won't be there. So, the next question. How can I fully dilute gas? What does this mean? If there is no EUV, simple radioactive substance can be ionized hydrogen gas. This is what we are developing now. There is a space technology which allows us to do ionization without radioactive material. Can bronze be used? Bronze, you can use it, but the alloys always create you a problem. In all your reactors, try to keep away from alloys. The alloys have double or triple magnetic gravitational characteristics, and this makes the control of the reactor very hard. Try to use mono material.
What is the best material you have found out to be the best material that can be used?
Depends for what job. For a space technology, one of the best systems we have found is plastic. A specific kind of polymers are fantastic. For energy, you can use anything.
Including glass? We can use glass too?
You can use ceramic as well. Ceramics are one of the best.
What?
Ceramic.
So Lady Dragon's pottery reactor could be the best reality.
Ceramic. Oh, but how can you keep a vacuum inside ceramic? Isn't ceramic porous?
Plastic is more porous.
They use glazings on ceramics for pottery to make them hold water and air and so on. But also the high-tech ceramics are way different than your ordinary pottery of the past.
If you use certain glazes, you can fire it at high temperature and have ceramic which is completely sealed. So there won't be any bubbles left in. Well, I'm using high fire glaze, and it's very dense. So there is no.
Who's speaking, please?
John speaking.
Hi, John.
Hi.
Where are you from?
I'm in Belgium. I'm in Dinant.
Dinant, okay.
I've been working glass and ceramics, and I'm using high fire, which gives ceramics which are very dense. I can even make pieces of ceramic that will make sound because it's like a bell, because it's dense.
I think, if I'm correct, there is some research done in Liège University on this with ceramics, and they set up a spin-off regarding this, if I'm correct. Ceramics are one of the best materials for reactors, but the what do you call it? The shock resistance to them is bad. When you get a magnetic shock waves, they crack.
Some of the new ceramics are reinforced with carbon or carbon nanofiber or boron nitride type fibers inside that make it pretty strong. Might be a possibility still that way.
Can I ask you, Rick, how is your project going?
Well, we've made some progress. We've got lots of new ideas, of course, but we've got a 4-inch copper globe and a 4-inch stainless globe to be able to start to work with, which I've tapped into and able to inject gases in with a septum seal across. You can use a needle to actually inject the gases into the sphere. I haven't really done much in the way of injecting gases yet. I'm still trying to figure out which gases I should be using, and also thinking about the same thing that Ludmil mentioned earlier, where there would be the use of a globe, basically, that could be special ordered with a certain mixture of gases, and use that to experiment with, rather than getting into the high vacuum system and a whole series of gases. It's a pretty expensive and exotic way to go, when perhaps we can order up a bulb, essentially, a globe or bulb out of glass, out of borosilicate lab glass or even quartz glass, with a particular set of gases, perhaps similar to what's found in the patent. The downside is you wouldn't be able to access those gases to be able to pump them out so easily without having a fitting and so on the glass globe, which may be possible as well.
You know, when you deal with the sealed globes, you don't have a control, first of all. Secondly, a lot of your plasma comes in touch with the wall, and you lose your gases. It's a very tricky. I tried globes a few years ago just to see how it behaves, but somehow you can't maintain plasma unless somebody can come up with a different way. And with the globes, with the sealed globes, keeping a plasma going is very, very, at the present knowledge I have, is very difficult. Unless you can come up with something, because you have to be able to feed hydrogen on certain points into your reactor. Because when you run a multi-core reactor, you see when you feed the new gases in, how the current in the plasma changes rapidly, and how the speed of rotation changes. And so when you have a globe and you still got the loss and the leakage into the body of the globe from your plasma, you'll find out very soon you have a dead chicken on your hand.
Well, I hope to keep the chicken alive by having the outer sphere, say my vacuum chamber that houses the globe, might have some other gases or other interactions. We were thinking maybe different, radio frequencies.
Yeah, but the plasma inside the globe, the inner tube or inner Caroline core, we call it, will leak to its structure, and it disappears. You have to find a way, a channel that you can feed hydrogen into your system.
Right. Yes. Well, we do have ways to do that as well, and the globe is one way of trying to do it without feeding, just with a basic system. You try to alter the atmosphere or environment around that globe in order to activate it and perhaps pulse it with the certain frequencies and high voltage or other radio frequencies or microwaves and that sort of thing. It would be an external stimulation rather than the more gentle method, it seems, that you use of actually injecting the gases into the core to get the thing going. So, in that sense,
very interesting. I said this before. When it's exactly 4 or 5 years ago, just let me check. I'll tell you something. I don't know if you know. Just wait something. I'll tell you. I'm just on Google. I'm going to check something. Okay. I'm going to tell you something very interesting. Today, they call it Mid Shaban. Shaban is the month in Arabic, in the Islamic calendar, and we are in the middle of it. On 28th of Shaban, which is another week, 10 days, at 5:30 in Tehran's time, is when we achieve the full lift of what I call a special program lift. So in a couple of weeks' time is the anniversary of the full spatial program lift through the gas mixture. I asked the Keshe Foundation team to register this here in Europe, that at 5:30 that day was achieved, the full lift. So it's 5 years, 6 years now since we have achieved in this multi-core system lift. And we've seen what the Iranian spatial program has done with the rest of it. Initially, these reactors are all plastic. And plastic itself has the ability to, due to the high vacuum, release hydrogen into the core. So you don't need to inject material continuously. If you create a condition with a special plastics, you have a continuous supply from the structure as hydrogen evaporates from the surface. So this becomes a way of keeping a self-sustaining sphere. Do you understand?
Yes, that makes sense.
So
it also results in a deterioration or a loss of some of the material of the reactor itself, the walls of the reactor. Is that right? Or you would have
it's so minute that it doesn't play that much game. Okay. Some depends on the material used, because I used a specific material and I coated it with a specific material again to control the leakage.
Okay. Is that some of the information that might come out in the next while after the testing's done on the new reactor?
No, this is an old reactor. This reactor is operational. It's been operational 5 years ago. But when you say you use a globe and the whole thing happens, it just brought back the 28th of Shaban in Tehran when we had the first lift.
I got you.
So initially, I understood that the material will release, because of the high vacuum condition you create, certain amount of hydrogen into the system. But there is no problem with the carbon factor of it, because the plastic is a carbon-hydrogen bond. The carbon stays in the outer boundary. It becomes an isolation or an insulation for the wall. And so the thicker that carbon layer gets, that you find out you get a more stable reactor.
Oh, yes.
When I explained a few minutes ago that I use carbon, and they said, how can you have a carbon as a gas? Plastic is one of the best things to give you carbon.
Okay.
Won't that change the pressure inside the reactor when it leaks hydrogen?
No.
And
the thickness of these walls is about 0.5 centimeter. You're not talking microns, and it's put it this way, the reactor is still getting tested, it's still on the condition, we don't see holes in it, it's 5 years on. Because the carbon gas itself becomes a blanketing layer. So it gets a point of, what do you call it, balance somewhere.
Right.
But at the same time, you still get certain leakage back in on the plasma. It's a very interesting concept. Initially, I didn't think about it, but later on, We saw it's a very stable. Plastic reactors are very stable reactors, extremely stable, because you don't feed that much, you don't need that much feeding, and if you know how to operate it, they allow you to produce a lot of beautiful molecules.
Would it make sense using methane in a metal in a reactor?
What do you call methane?
CH4.
Yeah, but to you is methane. CH4 depends how, that's what I said, what do you call methane? You can break the CH4 in a vacuum.
Yes, but my idea was, because you need hydrogen and have carbon in a gas form, introducing methane in the reactor, would that lead to the production of carbon in the gas form?
I don't know. I never tested it.
I believe they use methane in an argon environment to create graphene in some high temperature procedures.
There is an institute, there is an organization in Belgium which tries what I call to make popcorn, and they call it nanomaterials. And it's that's what it is. I call it
Popcorn.
They wanted to understand how we produce nanomaterial, so we spend a few lunch times with this group. It's a spin-off of Liège University, and they produce popcorn. So they allow something like methane combination to go into a chamber, high laser fusion type thing, and then you get exactly like a popcorn. It just pops out and it becomes what they call nanomaterial. According to what we understand, they use all the budget and they haven't managed to actually produce a nanomaterial. This allows the carbon of the CH bond to be released, and the carbon, what they call a nanomaterial. But I don't know any case that it can be done. It'll be very interesting. You should be able, but don't forget, if you break the carbon, the CH bond, CH4 bond, what do you get? Carbon and double molecule of hydrogen? Or would you get a CH3, which is the basic of life, the structure, with having a free hydrogen, but you never release the carbon?
Yeah, I think they can form different, I think they can form graphene from that process as well.
Yeah, but you need a high temperature, as you said.
Right. Yeah.
Okay, anything else?
Well, we've gone 2.5 hours. How are you feeling there, Mr. Keshe? Would you like to go a bit longer, or should we cut it off?
If there's a question, we answer.
Okay.
It says, so in the nanoradioactive reactor, we can try about two gases, hydrogen and nitrogen. Yes, you can, but be careful with the release of extreme ultraviolet, because you get burns on your reactor. You're better off to use helium if you know how to do it, because if you use nitrogen, then you need the radioactive material as well. How to start a reactor? Radioactive, ultraviolet, ionization. Either way, depends how you set your system up. Set a column or shell need to rotate. At the standard you work in, yes, it does. But if you can create a plasma of different strength, it will do itself naturally. What proportion of gases after adding gas vacuum should be how much? It depends on the size of your reactor. The size of your reactor decides on the gas mixture. because with a bigger cores, you need a larger volume of nitrogen to create that blanketing or helium that is spreads thick enough and thin enough. That allows you the ionization, but then you have to reduce the volume of the hydrogen. What kind of compact vacuum seal is used as a feed-through? We use ceramic ones. They are very effective, low, high temperature resistance on rotation. The vacuum seals, I sent the detail to one of the teams which is working on, they wanted to know what I use. We use a Teflon combination because it allows the temperature and the vacuum condition to be held. But it has a wiring inside the Teflon. It's a specific, it keeps the pressure on, but they have a problem with carbon binds that when you create a plasma, when you release high energy, what I call fields, they interfere with the structure of the carbon, or they dislocate the structure of the, what do you call it, crystal structure. This is one of the problems which I keep on saying, I think Ludmila understood it at the beginning, is that be aware of the release of the high MAGRAV plasma energies, especially when you're emptying your reactor, especially when you're extracting gases. When you're extracting gas like nitrogen in the outer layer, you always feed it into a steel tank, because if you by mistake let it go through your pump, very soon you'll find out you have no pump, because the energy which carries through the nitrogen, once it goes through the steel pipes or it goes through the 6mm pipes, the minute they get in to go through your pump, the energy releases to the softer tissue, which is the carbon bond of your seals, and then you find out your pumps literally become useless after a few tests. So this is one of the things you have to watch very carefully. What kind of compact? Yeah, but with the Teflon seals, you don't have that much of a problem with this. What is the easiest way to open receiver plasma in a metallic magnetic steel chamber? Rick, can you help with this?
Yes, I'm trying to figure it out here too.
What is the easiest way?
I think he's talking about the receiver as the generator or receiver, perhaps, or to receive the plasma in a.
Yeah, you see, it says very interesting. It says, what is the easiest way to open? I think this guy has listened to the other workshop. I think I know where it comes, if I'm correct. It says, what is the easiest way to open a receiver plasma in a metallic non-magnetic steel chamber, and how to maintain and control it? What gases we need to be added to H and in what amount? I think we answered this just before.
Yeah, that's the general, just there. I think.
Yeah, okay. I think we come to the end of the questions. There is nothing we can add. Is there any other questions before we say goodbye?
I would have a question. It is stated in the patent that liquid helium would be used. How can liquid helium go into the reactor at low pressure? And how can we take it out? How can it circulate in the reactor to release the scintillation?
The patent is written to cover every aspect. This has been written for a specific condition, and the liquid reactors are at the moment beyond understanding. But liquid reactors are more powerful and much more controllable than the gas reactors.
Funny you mentioned that, because we did have a design that we've been playing with the last few days using a sphere, in this case a copper sphere, and we have water inside our reactor, inside the chamber, and I have a magnetic drive. I can create a vortex of the water inside and actually rotate the globe. Now, so the globe is in contact with a fluid rather than a gas inside. Of course, you can't apply a vacuum to the water because it destroys your vacuum pump pretty quick and so on. You wouldn't use it in a vacuum. But perhaps, what I'm saying is perhaps the fluid can act as a receiver or a cooling agent for the core, for example.
I don't know, but you can, the liquid reactors, especially when you can use high liquid, what do you call it, very good mixture of the liquid, they will behave very easy and are very much easier to control than the gas.
That's exactly what I was thinking with that design. It seems like it's got a natural cooling system built in. At the same time, you could use the heat generated in the fluid to heat your home or to make power if you wanted to. If you're
but that heat comes out of the friction, not out of the reaction.
Oh,
that's what I think anyway.
That's interesting.
We move away from matter and we work in plasma, but there are planets which are liquid gas, and they have a very different magnetic gravitational field properties and performance. This is very interesting because if you look at the structure of the planets like Saturn, there is a lot of discussion about the material inside it, but we see the performance of the frozen dense liquid helium. We have shown the liquid CO2. When you have a dense liquid CO2 at room temperature, the behavior is totally different. And when you create a plasma and you create a condition, you release the energy, and this is very much the way our body functions by eating food. So liquid reactors is part of our own structure of our own body, but it changes from matter to the gaseous state. When you use liquid helium or other liquid gases, if you reach the position to be able to create gravitational magnetic field, your helium has changed from the matter to a gaseous state. And in transformation from one state to another, you release a lot of energy. You release huge amount of energy. That can create heat. It's one of the processes of creating heat. If somewhere in your process in the universe you want to create rapid heat, all you need to do is change the matter in its liquid form from the matter to a gaseous state. And as you know in the paper which has been published and is coming out very soon, this is how our body energy is created. Which is now they've developed, they talk about different processes, but when you look at the production of the gaseous state of matter, which we showed in Eindhoven 2 or 3 years ago, when the gas converts into gas, It releases huge amount of energy, which we run a torch and a motor with. So if you use liquid reactors, they are good for energy production or heat production.
There's another question from Gert here that he's written down. Are the rotative feed-throughs also ceramic ones? You were talking about the feed-through before for the gases, I believe. Is that correct? And this would be the rotative feed-through to rotate inner chamber or some sort of magnetic drive or something like that inside, I presume.
Somebody explain to me what you mean. I don't understand.
Well, maybe Gert will have to elaborate a bit on that question. Do you want to make it a little more specific, Gert, or clarify it?
Yeah. When you use a rotative inner core or something, I always have the problems to seal the vacuum from the atmospheric pressure. And my question was what kind of vacuum seal can be used or exist to use it for this kind of system.
If Rick keeps you busy talking, if you want to discuss things within each other, because I've seen this question be raised quite a few times, it takes me a few minutes to get it and give you the name, if that's okay with everybody.
Okay.
Or we post it on I post the name of the seal on the forum later on today, that everybody knows what is the best we use.
That would be really, really great. We're having the same issues. I rack my brains trying to come up with solutions.
I dig it out of the invoices. Yeah?
Excellent.
Just keep talking to each other. I know this is vacuum sealing is a big problem for a lot of people.
It's true.
So,
it's really.
Yeah, keep on talking. 5 minutes, I'll be back. Yeah.
Okay. Sure.
Okay.
Thank you.
Yeah. Thank you.
Well, it is a problem. I thought of the ferrofluids at one moment, but the answer given was a kind of O-rings, multiple O-rings. Is one answer. I think Mr. Keshe gave a moment ago. Well, in fact, cutting into pieces the differential of pressure is one kind of answer.
Yeah, that was quite specific, actually. I need to go back and re-listen to that to get a more clear idea exactly what he means.
Well, he said 0.7, whatever that means.
That's 0.7, I think it was bar or Pascal, one or the other. And then he talked about -4 and then, or -3 and -6, I think, is the different sort of levels there.
No, he mentioned the name of the seal is 0.7.
Oh?
Whatever that means, kind of a part number or whatever it is.
He's going to find that out apparently now and get back to us in the next few minutes.
I think it's a millibar. I think he means a millibar.
No, he was talking how the pressure with using multiple seals is increased, but actually the vacuum is holding. But the problem when he said the part is 0.7, whatever that means. Maybe the thickness of the material, or maybe some kind of a part number, or who knows what that is. At least I don't know, actually.
I tried to make some seals with the O-rings, but I get a lot of resistance for the motor.
Yeah, I looked up rotative feed-throughs and been researching that a bit, and boy, are they ever incredibly expensive to get the proper ones.
Yeah.
Like you're talking like $2,500 for this stupid little thing that seems so simple that anybody can make it in a machine shop in half an hour. But it's not quite that easy. It's got special magnets inside and special magnetic fluid and so on.
I made one ferrofluid feed-through, rotative.
Right, I remember you.
But I get to 75% of vacuum, and that's all.
Huh? Yeah. And did you design it similar to what the so-called commercial ones are like?
Yeah, I try to.
I see. And you're like a machinist or whatever. You have some machining capabilities, don't you? Or do you job that to someone else? Yeah.
I'm a teacher in mechanics.
Right. Okay. So it's not like you know what
that makes your life easier.
Can I ask a question? Why don't we see the Dutch or the Belgian reactors? If you've developed it, why don't you show it?
Right now, you mean?
No, post it on the internet or send it to me. I'll post it for you.
You mean Gertz or
Gertz or John?
Gertz has been putting his on. He's got 7 videos now on his reactor.
Yeah, I haven't seen it.
Oh, you must see them. They're quite nice.
Yeah, put the link on the forum, the same we done with the Chinese, the same with John.
Do you have a playlist, Gert, or is it...
I post them on the forum from the Netherlands group.
Yeah, forum, go on the... Not many people go on the specific languages because they don't speak it. Go on the main forum and post it.
Okay.
The same with John, because I said there are the 13 nations we know scientists who are working and doing things. So you're proud of what you're doing and not just share it with the Dutch or the Belgians.
Which topic I can use?
Just go on the reactors the way I did with the Chinese.
Okay.
Yeah, so use that one. The seal I use, the vacuum seals we use, is made by GAR Lock. Gerlock. GARLOCK. I write it down that you can see it.
Gerlock.
Gerlock. Yeah, I found them one of the best ones because they have different seals. You can use bearing seals. Somehow.
Gerlock Holland? No.
Yeah. Can you see it? I typed it in, but I don't see it.
Okay.
Yeah, it is Gerlock. And then it's a PS seal. You have to use a PS seal. It's called a shaft seal. Seal. Because these are very good for, they have like a rubber spring in the middle, which hold tight to the center shaft with the rotating shaft, or you can use the one which is a steel one with a rubber on either side of the bearing, which creates a very good vacuum. But if you use a double, you can go up to minus 13, 14 bars, and the seal still holds. Put it this way, this is what we use for some time, and it seems to be. But if the system overheats or you pull it too fast when you're loading it, you find there's like a spring ring inside the seal, which keeps it tight.
I haven't.
I write all the information down in my mind. Just hold on. Yes.
I'll just post here's Gert's video channel as well for folks that want to have a look at his. Hopefully it'll come through. Let's see if.
Can you please post it on the main channel and the same with John?
Yes.
You can have a look at your ceramic. I'm going to write this down that you can see. It's called PS Seal.
Yeah.
Okay, there we are. This is the seal we use. It's a PS seal. The comma is in the wrong place. So it's called PS seal. The name is, as I've written it down, it's a German thing, and it's fairly good. But to get the best seal, you need to use 2 of them. And it allows you to go to -9 bars.
Well, that's good information, and we really, really appreciate that little nugget at the end of the show here. Thank you.
Yeah. Okay.
If you need any technical knowledge, if you have it, I'll give it to you, but you got to ask what you have. But I remember this seal is a problem. Some people know it, some people don't. With these seals, you need to use a lot of vacuum grease or not vacuum oil. The way to do it is to add the grease from the side away from the core.
Right.
It gives you the lubrication, but the grease doesn't seep into your reactor.
Mm-hmm.
Yeah. So what you do, you apply it on the away wall of the seal from the core, and when you put the shaft through it, just enough comes in without seeping into the reactor, into the core.
Let me ask you this, Mr. Keshe. Are there times that there's actually a positive pressure within the reactor that the seal might have to
Yes,
deal with?
there is.
So
There is.
it's important for seals they're usually designed to go one way, like against pressure.
Yeah, but the problem, the positive pressure comes when you get vapors.
When you get wafers?
Vapor.
Vapor.
Okay.
When you get a couple of drops of by accident or situation in the reactor, you produce moisture. That moisture becomes very lethal, and it has to backfire somewhere.
Right.
Yeah. When you open your reactor, if you have that kind of facility, because most of our reactors can be reopened, you see where the moisture is being created.
Mm-hmm. Right.
The moisture creation is one of your biggest problems, and because usually your seal is at the bottom, the moisture seeps in, and then you got a back pressure. Magnetic plasma pressure is not that much. I haven't seen any. If you use, I don't know how you feed your rotating, what do you call it, central columns. Do not connect the central column to a motor. Use 1500 revolution valve, which means your what do you call it, your gas pipe are always isolated from your central column. I don't know if you know this system or not. You can buy, the connection valves which you connect to your reactor. You add a valve. It costs about 70-80 euros, but these valves rotate up to 3000 rev if you find a very good one. So you allow your reactor to run at any speed you like, and you feed through a rotating valve, not a fixed valve, because then your pipe goes in a twist, as you know. But these kind of rotating valves allows you to operate and test condition constantly. You don't need to stop your reactors. Because with a fixed valve, if you're using central column or any other reactor, you have to stop to reload. With a 1500, 3000 revolution valve, valve is about 7 centimeter long and it seals inside, but it allows you to feed gases on a continuous basis for different tests.
Nice.
This is what I've used for nearly 7-10 years. It's made in Germany. So it allows you a continuous test, because when I start the reactor, I hardly stop. By the end of the day, you already done 200-300 tests. So you don't need to stop every time. You can take the central column, retract it, put it in. You can do all sorts of things with your reactor. You change the combination, you extract through the central column, but through revolving, the valve. These revolving valves, I try to dig the name out for you to show. It's a German made, and they stand up to minus 10, 14 bars. So you instead of stopping every test, you constantly can carry on whole day testing different combination of gases and different combination of plasmas.
Nice. We're hoping to use a needle to do on-the-fly changes to the sphere gases when it's rotating, and stick it through a Septaseal to be able to either pull off gases or stick gases in using a standard hypodermic syringe, basically.
Yeah, but when you but you cannot test with the plasma running, huh?
Well,
because then you insert the syringe, if it goes in, it's like putting a needle in a balloon. You lose your plasma.
right, okay. Well, what if the needle didn't go right into the sphere and only went into
how can you deliver gas if it doesn't go right in?
Well, it would have a little...
it's a chicken or egg, which one?
Well, there's a sphere, and then if you had a hose going into the sphere, you'd have the same issue. In my case, I can stick the needle into a little hose going into the sphere, say. It could be a plastic hose and isolate it, maybe.
Yeah, but what vacuum do you keep your sphere constantly?
Well, you could pull off, you can use the syringe actually to create a bit of a vacuum in the sphere by,
You see, if you use these rotating valves, you can, on the wing as you're testing, you can reduce or increase the vacuum as well.
Right, yeah.
This rotating valve, let me check, I can tell you. I'm just going to go on the internet. This gives you a flexibility beyond in testing. That's why when I tell you we test this and that, it's just because we have the flexibility of
just being able to do that.
Yeah. Then you can do all sorts of tests.
Right.
So this is rotating the reactor, or just central?
No, the valve rotates outside. What do you call it? The valve, is independent of your reactor. Your reactor rotates. The valve is connected to it, but the piece where it connects to your gas feed or your vacuum system is rotating on its own, or it stays stationary.
Right.
Yes.
It's a union, I think they call it.
On the shaft.
Pardon?
Probably a rotative union or something. Usually a union, I think they...
I'm just trying to dig this out for you.
So this is the central column that's rotating, right? You're talking about.
You can rotate the central column, but at the same time, at the end of the column, you add this piece, this valve, and this valve
you can feed the gas in. I understand that.
Feed the gas in, create different kind of rotation. You create different kind of mixture. You can add mixtures in. You can add even radioactive gas in. But your system is continuous. And then you can do, if you use a multiple core, you can do it with all the cores.
Yes, I understand that. I'm just trying to figure out which part of the reactor is rotating. Is it the central column or the whole?
If you have a central column rotating, outside the column, because the column has got an extension which is outside, where you connect your motor for its rotation.
Right.
You make a hole at the end of this column, and you add this, what do you call it? This rotating valve. This rotating valve at the end. So this gives you enormous flexibility.
Yes.
You can get it in the quarter an inch, half an inch diameter. And it's just about, I pay about 60 or 70 euro per unit. And I always keep 3 or 4 because sometimes the seal goes.
Allow me to ask a stupid question. Why do we need a rotating central column?
Or even if you have a rotating sphere, if in your reactor, your core rotates, you add this to it.
Right.
The whole reactor rotates?
Yes.
Or it rotates by itself? Or
no,
through a motor?
It rotates with the motor, and then when the plasma takes over, it rotates on its own.
I see. So that's how you rotate the plasma inside the reactor? By rotating the whole reactor?
In some cases, yes.
I see. So instead of using a butterfly stirrer, you can rotate the whole reactor also, right?
Yeah, but then you need the military engines.
You need the miniature...
Military engines.
Military engines are very small, and they are used, for example, for lifting the cannon on a tank.
Mm-hmm. Mm-hmm.
This gives you power to take 15, 20 kilo or 10 kilo or 6 kilo reactor core. A normal engine doesn't allow you to do these things.
Exactly.
I see.
Yeah, because when you're rotating your core, the core, if it's made of steel and a 15 centimeter diameter, at least it weighs 5 kilo, maybe more.
Okay.
With a half a centimeter or 0.7 mil diameter, what they call it, thickness. To keep a motor like this running for hours, you can't use a normal engine. Some people use different engines, or some people go for a small 3-phase motors. But if you can get hold of the military motors are very compact. They're about 7 centimeter or so. They're about 3 to 4 centimeter in diameter, and they are used in some cases to adjust cannons in the tanks. So you can imagine how heavy the cannon is. So these military motors are very handy for these kind of tests. And you can run the reactor for months and months.
Mm-hmm. Now, in your reactor that you demonstrated during the peace conference, the 3 external motors seems to be just driving and in the central column instead of the whole reactor, right?
All of them, everything. This is a very specific design. This is a very specific design for a specific job. And these motors are doing things which you think, but they're not doing what you think. Put it that way. Sorry about that. We're not trying to
true of most
confuse.
of the reactor.
No, we're not trying to confuse anybody. It's just that, as I said, you get only 1%, 2% of our knowledge.
Yes.
The rest is hidden behind what it is. So these reactors, what you saw, is extremely advanced technology. It's extremely advanced. And as you know, April, May, June, July, it's taken us 3 months to set it. It's not just the physical structure, it's the rest of it which needs to be set to create a condition. I emphasize again, for anybody who's trying to test or build a reactor, step outside the present way of thinking and do not go to build things. Go to create condition to achieve. It's a very big difference. You can go in your kitchen and take a tin pot, you can take a Coca-Cola can and make a reactor out of it. If you step out, the reason we create or develop these kind of sophisticated reactors is for test reason. Because once we go into production, we take that production condition from that result. But when you invest, this reactor which you see has cost the foundation tens of thousands of euros. Yeah? What you see shown to you might create, oh, it just cost, but it's been created, even the cutting of it, even the shape of the cut, the tool which is used to cut the material has been calculated to give certain effects. So when we achieve the result, that condition will be repeated. So when you play with your reactors, go for creating the condition, not developing a reactor. Am I
Understand.
clear?
Yes, understand.
So in the universe, the condition which is created leads to creation of something. When you create a condition, leads to creation of Earth. So in all your tests, do not go for building a reactor. Go for creating a condition. Then you play God's game. This is the point which a lot of people miss. They go and they build the reactor, they copy the patent, yeah? We built complicated, sophisticated systems. But a tin pot tin can create the same condition. But you have to understand what condition you want to create. The reactor you saw in the peace treaty, this is for totally a new understanding of the condition which is created in the universe where there is no nuclear material, but ionization and opening of the plasma happens. I understood it maybe 6-7 years ago. It took me 4 or 5 years to work it out and develop it. And when we saw the pressure coming from the Belgian authorities to block us for the nuclear material, I brought the process to create a condition. The whole test with this reactor is going to cost at least 200,000 euro. You don't have that kind of finances. So you do with the smaller amounts, you do with the smaller things, but you create the same condition. But as I said, with the rotating valve, each valve costs 60-70 euro, and you can build a reactor for 60-70 euro. You use a small pump, vacuum pump, we had to wait nearly under a year for our vacuum pump to be designed and built. It cost tens of thousands of euros. You don't have those facilities. As a research organization, we have the facility. So we try to create a variety of conditions. We have what is called a three-dimensional magnetic field detector. I can put this detector anywhere, meters or next to my reactor. I get a full three-dimensional magnetic field strength in that point. This system costs tens of thousands of euros. But when we build a reactor like this, then we put the detector on the left of the reactor, at the bottom of it, on the top of it, to measure the magnetic field, gravitational field in different points of the reactor, to see if we have a homogeneous magnetic field, gravitational field. So when you see the reactor like the one you saw in the peace treaty, there is a lot of elaboration, but a lot of it is not needed. But we have to consider every eventuality, because if in the middle we want to change our mind or add something, then you have to wait another 3-4 months to be manufactured. So we manufactured the maximum possibilities we could see to rotate the core, to rotate the center, to retract the center, to allow 3 centers run together, to allow plasma to be unbalancing one side and balancing one side. These are the things we test. That's why you see such a complicated system, because we have to enforce a non-nuclear condition. A non-nuclear condition has to be tested.
Got it.
Mr. Kesh, I have a question about the pressure used by the gases for the inlet. I do some tests on a vacuum table I made, and I used, let's say, 3 centimeters of tube, diameter 4 inside, with pressure of air. It's the easiest way. A pressure of air of 1 bar. And I tested it with 1 atmosphere also, and of course the expansion of the gas in a vacuum, in a balloon, you can see it actually. It's a big difference. My question is, what kind of pressure for the inlet of the several gases is used for that?
The way I always done is I vacuum the whole chamber to minus 10, 12 bars, and then
is this bars or a millibar?
Millibars.
Minus 12 millibar.
12, yeah, we achieved minus 12 quite easily with our system.
That's a lot.
The way I do it, the easy way to achieve such a rapid situation is, as I said, and most of you do it now, is to have a reserve tank. I keep my tank always as minus 10, 12. Yeah. I just open the valve, pull up, it's done. I don't need to wait. So when you do that, then I have built a special gas feeding table, where this special gas apparatus, I built 2 of them, is allowing me to have the central chamber at minus 10, minus 12. And then I open all the channels in one go, so all the gases get sucked in together.
Yeah.
You understand?
Yes.
So the suction is very rapid, or I make my own mixture where at the end of the system, I create I have a gate closed. I open a double gate, and because it's already vacuum, the mixture just gets sucked into, and then I suck the mixture back into the reactor. And then the vacuum condition of the thing is balanced between the 3 or 4 gases, so they separate themselves. In some cases, I feed individually, but as you feed individual gases, you lose the bars, the pressure, the vacuum pressure, and that doesn't work so good.
Yeah.
So,
mhm.
so you create a vacuum outside before you feed it in, and you make your mixture yourself before you feed in.
Okay. My question was the pressure of the gases before you let it in. Is this atmospherical pressure or some more?
It's more than
half
atmospheric.
bar.
I use the gas pressure. I put the gas the meter at 1 bar.
Okay.
All the gas cylinders. Yeah, because if you're using cylinder gas, you have double control, huh?
That's 200 bar or something.
Yeah, you put at 1 bar or whatever you can do, and when all the 3 gases are on the same pressure, then you get the balance amount. You can actually measure the molecules of the element you're feeding into your 3 or 2 centimeter or 1 centimeter pipe.
Okay.
Yeah. It's the way the universe works. You create a condition to suck in, and then you block it, and all 3 gases are at the same pressure from your main gas cylinder, so it cannot be any difference, more or less. Then you close the gate, and then you feed the 3 into a central bar or central pipe, because it's already in the minus 10, 12 itself. You lock the gate behind, and then you open the gate into your reactor core.
Okay.
Then, because originally I used to feed nitrogen to go out and then do the helium and then do the hydrogen. Then you find by the time you put the hydrogen in, you disbalance the vacuum condition. You understand?
Yeah. Yes.
This is the way I do it, and it seems to be working. It took me nearly 2 months to design the system and build it, but now I have 2 setups so I can run 3 or 4 reactors at the same time from the 2 setups, or I can run different chambers. I can change the character of the chambers before it's fed into the chamber. One system feeds the inner chamber, one system feeds the outer chamber, or you enter one gas from one end of the reactor in different mixture and see how the gases interact in the plasma in the center. You play different games with it. It's about 20 centimeter by about 50 centimeter board with all the things set on it. And then you can control your vacuum directly from the same board. And you control your exhaust as well through the same board. So you have full control, and you always know by the position of your valves which valve is open and which valve is closed. You never make a mistake. Because one of the problems sometimes is, without you knowing, you open your vacuum cylinder into the gas cylinder, in the feeding cylinder.
Yeah.
This way, everything is blocked because I use color-coded pipes, so every gas has got its own color, and you know which one is open, what's been in, what's out.
Yeah. Is it possible to use to make the concept with a single core and get results of it?
Yes, we done single core.
Okay. I use the single core because it's the easiest way, I think.
Where are you? You're in Holland.
Sorry?
You're in Holland.
No, Belgium.
In Belgium.
Yeah.
Whereabouts in Belgium you said you are?
I'm from Zwieberhem. I think it's the same village where your wife grew
My
up.
wife comes from.
Yeah, yes. I spoke to your wife before.
Yeah, she was born and bred there.
Yeah.
If you the valve which you can use if you want to use it, if you go to Ghent, come off the Ghent Bruges junction. As you go into central Ghent, is on the right hand side. You can buy all your pieces from them. It's called all the valve, rotating valves and things like that. You can buy from them.
Okay. Can you spell it on the text, please?
Yeah, it's the name of the company is called Air Compact.
Compact.
Air Compact. I think that's how it's spelled. Hold on a second. You can buy this rotating valve from them, and they are very good, reliable.
Air Compact. Yeah. Okay. Thank you.
Have we got any more questions, or should we let Mr. Kesh go now after 3.5 hour discussion here?
Well, I have a small question, just a precision. Mr. Kesh, when you talk about -10 or -12, is that 10 to the minus?
Seems to have disconnected there.
It's disconnected.
I think he meant the 10 to the minus 10 millibar, I think.
Yes, I think so, sir.
Yeah. Well, that's a lot.
See, sometimes talks about 10 to the minus 12 is what they go down to too. So to evacuate the chamber to start with, but it seems to be the gases are nearly at atmospheric pressure by the time they're added to the chamber. Depending, some of them are still under a vacuum. Depending.
Yeah.
Yes, but the thing of using an intermediate space where you put in the mixing and then from that you use it to put in your reactor seems to be a good way of working.
I will do some more tests on the vacuum table with different pressures by, let's say, an inlet of 3 centimeter, 4 centimeter, 1 bar in it, and I can make a video of it too.
Great, thank you, Gert.
Hello, I'm back again.
Yeah.
Oh, okay, great. Say good.
John, somebody was asking a question.
Yes, that was the question of the -10 or -12. I understand it as 10 to the -10 or 10 to the -12, the pressure.
Yes.
Okay. It was just a clarification.
And that was millibar you're talking about, correct?
Yes, very well.
Yes.
Okay.
There is a mistake I've made in that Air Compact. It should be 1C, it's got 1C too many.
Right.
Yes, so you have to delete that. Okay.
It's aircompact.com. I have it here.
They have a collection of these, what they call these connections. Usually takes them 2-3 days to get it for you. It's known as 1500 revolution valve.
Right on. That's great information again.
Okay.
Okay, I think we should wind it up, guys, eh? It's been
Thank you very much for everything.
Thank you very much.
That was an outstanding session, I think.
If you build reactors, put them on the main channel. The more we open the more we put things on the net, on the forum, the less pressure we get from governments. They see the openness and there are different nationalities who are doing it. American government has blocked a lot of things to do with Keshe Foundation. American government has put a legislation in that no contribution can be made by Americans to the foundation, even regarding the banking. So we see more and more pressure to close. But on the other hand, with more people able to show what they are doing, it takes the pressure off the government on the foundation.
I started a new thread on the forum, Belgium, Dutch and Belgium concept. But it has to be moderated.
Yeah, it's just we don't have. There is a lot of development going on with the website, with the webmasters. So we're trying to, or they're trying to write every program for us that it cannot be secure and safe.
Yeah.
The teaching program will start on the week of the 9th, once the program is completed. And we will post things on. It's just that it would be nice to know, is there a program for July, Rick? Have you organized anything for July?
I haven't started to think about that yet. No. What would you suggest? Is there something you would suggest along those lines?
I think we host the preliminary, yeah? We might host August or September in the Keshe Foundation lab.
In August or September, okay.
Yeah.
And what for July? Sorry, I think I missed that.
August or September.
Right. So
we'll do we'll try. This is my thoughts. I don't know if physically we'll be able to do it, but we'll try to do a live test in August, September in the lab.
Okay, that would be great. And for July, we'll let it go for now and just do the learning program.
We'll organize as well for July with somebody else, like in Holland or in China. We got to bring more and more people online to be able to do it. Maybe by August we'll have the streamline. Then you have large numbers on the board.
Yes, and we might be able to find a different way to stream as well through the Skype and so on that might be able to include more people.
Yeah. Thank you very much, gentlemen. Have a nice morning, evening, and night, wherever you are.
Yeah,
thank you very
much.
Thank you very much.
Thank you very much.
Okay, thanks. Bye-bye.
Bye-bye.